This is Dubious Insights, and here we have a car, and the car is trying to park in this orange spot. The orange spot's going to move around to one of 4 different spots to try to not overfit this car too much. The car is hooked up to a neural net using Neat, and the neural net is going to run 240 generations with 40 children per generation. I've condensed this down to 3 minutes, and if you watch the end of the video, you'll see that the results are surprisingly mediocre. Honestly, this car did not park as well as I wanted it to. And I don't know whether it would have done better if I had let it run for 2,000 generations instead of 200, or, you know, if there's something wrong with the fitness function or the data I'm giving it. With this kind of input, there's 2 things that are probably the most important. One is the data that you're giving it, and the second is the fitness function that you're using. The fitness function I'm using is penalizing the car based on the distance squared away from this orange dot. It's penalizing the car based upon its speed at the end of the 15 seconds, and it's penalizing the car based upon the angle that it's at if it's not at 0 or 180 degrees. Now, some of these are obvious. Distance squared, you know, the closer you get to the parking spot, the better. Speed, I'm actually penalizing based on speed cubed because I want the car to actually stop at the end of the time and not, you know, it doesn't do me any good if the car is going at 40 miles an hour. And angle, I'm penalizing an angle, the square of the angle. So it could be 90 degrees off and now we penalized by 90 degrees squared. But that I'm only doing that penalty if it gets close enough. Otherwise, I'm just giving a flat, big penalty. And then if it gets close enough, it starts to get a penalty based on the angle if it's not at 0 or 180 degrees. And the reason I did that is that without that, if I just straight up penalized based upon, you know, being at 90 degrees, this car just didn't turn. By the end, we do see some good things. We see that the car kind of mostly ends up at, you know, 0 or 180 degrees. Not yet, but we will. Usually most of the cars get to the spot, but the behavior that I see that is bad is these cars what they always do is they go above the spot and then try to do a hard turn into it. Nobody, for the most part, nobody ever tries to, you know, pull straight into it or kind of go, turn and go straight into it. So I'm not sure if more generations would do that, or I don't know. The data that I'm giving it is its distance from the spot on the vector it's on, its distance from the spot on a perpendicular vector, the angle that it's currently at, the angle it's currently at and the angle off from its ideal 0 or 180, and time, the time remaining before we hit, we actually do the scoring. So, you know, after 240 generations, the car does okay. I'll probably be playing with this some more to see if we can get it better. So thanks for watching. This is Dubious Insights.